All right, it's time to talk about the other side of events in Node. libuv, the event loop, and non-blocking asynchronous code. We've already seen the event emitter, the custom events that are JavaScript-based that exist inside Node. And we said that that was really just a trick. It's really just an object with properties, and those properties are arrays of functions. But the other side of events is where it gets really deep and interesting. System events, handled inside the C++ side of the core, are actually handled by a C library called libuv. That's also embedded inside Node and is used elsewhere. But the idea here is managing events coming from the operating system closer to the machine. So inside Node, we have V8. We've already seen this. And JavaScript is synchronous. So V8 runs one set of code at a time, essentially one line of code at a time, and finishes that execution. And that keeps happening as functions are called, etc. Now also inside Node is libuv, another library. This one written specifically to deal with things happening lower level, events occurring in the operating system. So libuv connects by requesting something from the operating system. Let's say it requests to download something from the internet or to open a file. And libuv inside of it has this queue, a queue of events that have completed. And this may be happening simultaneously while V8 is running its code. And inside libuv, the most important part is called the event loop. And that's a loop in which libuv is constantly checking the queue that something has happened. And this again is happening while V8 is running. Then at some point the operating system, and this may take a while depending on what you've asked of your computer to do, to download a large amount of data, to open a file, whatever the case is, or perhaps the internet connection is slow. Whatever happens, it's an event. And that event will get placed in the queue from the operating system. And there may be more than one between checks as the loop is looping. So on every loop, libuv checks the queue, and the operating system may put more than one, hey, I finished that, inside there. But while checking in that loop, libuv sees that something is complete, it processes it, and it runs a callback. That is to say, code that is meant to be run when that event completes. It's some code that we've said, hey libuv, this is code that should run when this other code is finished running. And so we call it a callback. And it's very similar to the idea of an event listener. But that callback ultimately will involve, and usually internally, JavaScript code running as a response, but only when it's finished running any other code that it's running, because JavaScript is synchronous, so it can only handle one thing at a time. So JavaScript code may be running currently, and an event comes from the OS, libuv, checking the event loop, sees that it's complete, and tells V8 to run some code, but V8 will wait to run that code until it's finished running the code that it's currently running, because it's synchronous. But this entire process is asynchronous because there are things happening in libuv and V8 at the same time, and all of this inside Node itself. And when we talk about Node, sometimes you'll see a tagline that looks something like event-driven non-blocking I/O in V8 JavaScript. Well, we understand that V8 is embedded inside of Node, and that's what's executing the JavaScript code. And we see now when we talk about I/O or input-output that these are things happening at the operating system level, opening files, connecting to databases, and retrieving and sending information over the internet. These things happen at a core level within your computer system and within a server. And so the event-driven part is where we're asking for these things to happen, and then we're getting an event notification when it's done. So we get this event in the queue, the event has happened, and the loop is constantly checking for that. And because your code, your JavaScript code, can continue to run, this is called non-blocking. Big word alert. Non-blocking, meaning doing other things without stopping your program from running. And this is made possible by nodes doing things asynchronously. A blocking process means that, for example, let's say I said, go grab me this file, please, and get the contents. And then I waited for the entire file to be read and all the contents to be pulled into memory, and then I moved on to the next line of code. The problem with that is, as you get many users, and perhaps there is a variety of times that it takes for these things to occur, maybe the server slows down for some reason, maybe the file is extremely large, then you would end up blocking the next thing that you can do in your program. Your program would essentially seem to freeze while it's carrying out these other tasks. But with the non-blocking approach with Node, we ask Node to go off and do something else, and our JavaScript continues running. Our program continues running. And then when the next time is available, when the V8 engine is no longer busy, if an event has occurred, then libuv within the Node architecture is used to run more code in V8, functions that we want to run internal to Node. And then the event emitter also lets us run our own code, because usually those events coming from libuv are also related through the event emitter, the JavaScript side. They cause a JavaScript event so that we also can add our own functions that we want to run when something has happened. Now, asynchronous code is not new. It's something that has been around forever. The idea of a computer doing more than one thing at a time. But it's often been difficult to program with. This idea of having multiple sets of code running simultaneously is hard to manage from a code perspective. And so Node lets us write synchronous code in JavaScript that's very easy to manage and still respond to things that are happening asynchronously. So we've eased what it takes to deal with simultaneous code running, because we're never really dealing with it in a way that we have to worry about how the simultaneous code affects each other. Instead, we simply say, please run this code when this thing over here is done, and meanwhile, we'll keep running this other code over here. All right, so that's the idea of the event loop and non-blocking event-driven architecture that is at the core of Node.js, and what helps Node.js be very performant, high performance, because many people can ask for the server to do many things and we won't block. We'll keep running JavaScript and people can keep coming in and requesting things to happen, and as things finish, we respond. All right, let's take a quick look a little bit closer at libuv. Libuv actually has its own website. As we said, it's a module that was built primarily for Node, but can be used elsewhere. It's C code. And as we can see the tag here on the current website as of the time of this recording, it says asynchronous I/O made simple. So, in other words, as we said, helping us to manage more easily when multiple things are happening simultaneously. And you can go into the documentation and read more about the design patterns and concepts within libuv. I'll just click on Show Me the Code, and it will take me over to the GitHub repo, github.com/libuv/libuv. And just to show you an example, if I go into the src folder, the source code, I'll see that it's a bunch of .c and .h files, so I'm dealing with C code. I'll just go into the Win folder, just to show as an example, and go to the core.c file. And if I do a search for uv_run, this is libuv's primary loop about to be run. In fact, when we said the event loop, that's exactly what we meant. See that? That's a while loop. That is the event loop. And this while loop keeps running inside this C code, checking for things to invoke, checking for events to have been completed and callbacks to run. And so this is constantly running in the background. And as long as there are events that it needs to listen for, it will run and wait while our V8 code is running, while our JavaScript is being processed through V8. And when it finds something that is completed, when there's something in the queue that has been done, part of this asynchronous process has been completed, then it runs some code that we've said needs to be run when that particular task is done. This is the foundation of how everything really works under the hood. So again, an actual loop. So we're running synchronous JavaScript while inside the C++ core of Node, asynchronous processes are being handled, and they're helping us deal with them in a simpler fashion. All right, let's move on.